Okay, so in this second video on indices, we're looking at some of the harder questions at the end of exercise 6A of the Cambridge Maths. So there'll be, I'm just picking out a few questions and then you'll have a chance to do the rest of these questions yourself. So we're looking at the problems that we have with negative indices. So in this particular one in question 15, we're asked to write as a single fraction and you can't have negative indices. Okay, so we've got a few options, but I'll try to do it in the most simple way. Okay, so we're looking at a to the minus 1, so that's just 1 on a. We've got a minus sign, and b to the minus 1 is 1 on b. So we've written them as a fraction, and we've got no negatives, but they're not a single fraction. So what we have to do is look for the common denominator. So the lowest common denominator when the letters are different will just be AB. Okay, like for instance, if we had something with thirds and something with halves, the lowest common denominator is 6. The numbers are different, so we need both of them. So these numbers are different. A and B are different numbers, so we need both of them. So what's going to happen is it's just going to be like a cross multiply. So we cross those two across, and then the B comes across, and the A comes across. So 1 times B is B, minus 1 times A is A. So now we have a single fraction. So what's happening with this first fraction here, A is turning to AB, so it's being multiplied by B, so both top and bottom are multiplied by B, and here top and bottom are being multiplied by A, but what we do is like a little triple crossover. Okay, now we have a single fraction with no negatives. Okay, in the next one, again we've got a few options. We could do it, just sort of playing around, so what we could do is we could just turn, because this is a negative here, we could just turn the number upside down, but we can't change the bracket at this stage. Okay, then we can say inside the bracket we've got 1 on x squared minus 1 on y squared, because we're just flipping each of those letters around. And just like we did in the previous question, we've still got 1 over, but inside the fraction these numbers are different. So the common denominator will be x squared, y squared. So we're doing the crossover again. So y squared will cross over to the left. X squared will cross over to the right. And this number down the bottom, because we're dividing by a fraction, we're going to multiply by the reciprocal. So what happens is that number comes up to the top. So we get x squared, y squared over y squared minus x squared. So this number, like this is division. Okay, so we're dividing by a fraction. We're dividing by a fraction, so we multiply by the reciprocal. So the reciprocal is that this denominator here will end up coming to the top. Okay, so there's a few more in question 15 for you to practice. But let's keep moving on with some of the other harder questions. So in question 16, it says, there's an example with 12 to the end, but we want to write these expressions with prime bases. So primes are the smallest numbers, 2s, 3s, okay? For instance, 4 and 8 are not prime, they're both composite numbers. So what we're looking for is, what's the lowest number? And the lowest prime is 2. So 2 is okay, so that's 2 to the end. 4 is 2 squared to the power of n, and 8 is 2 cubed to the power of n. So that's fine, and then we use the multiply law, so it's 2 to the 2n, and then it's 2 to the 3n, and then we can use the first up here was the bracket law, and now we can use the multiply law. So n plus 2n is 3n, plus 3n is 6n. So we've converted into a prime base. Now this next one looks a little bit harder, but we've got 9s, 3s, and 27, so 3 is the prime. So again, I'll go down a bit. So 9 is 3 squared to the power of n plus 2. 3 is okay, don't have to change that. 3 is to the power of 1, and 27 is 3 cubed to the power of n. Okay, and then we use the bracket, the power law with brackets. So we've got 3. So 2 times n is 2n. 2 times 2 is 4 times 3 to the n plus 1. 3 is just 3 to the 1, and then 3 to the 3n. And then we can go across the top, we've got multiply, so we're going to add. So 2n plus n is 3n. 4 plus 1 is 5, and across the bottom 1 plus 3n is 3n plus 1. And now, that's a 5, yep. And now we can use division law, which is subtract. So 3n minus 3n is nothing. 5 minus 1 is 4. So the answer is just 3 to the 4. Okay. And again, in question 16, there's heaps of those to practice. Copy that down and come across. We've got a few more slides to go. So in next one is question 17. And there's a plus sign in between. Now, there is no law for adding with bases. So what we have to do is look for some other way to simplify. And the answer is we factorise. So what we have to do is we sort of unengineer that term there. So if it was a plus here, it came from a multiply. So for instance, if that had been the question, when we multiply, we add, so we get n plus 2. So what I've done is I've reversed it. So n plus 2 as a power came from a multiply. And then we've got plus 7 to the n. And then we can factorise. So the common term, there's a 7 to the n, there's a 7 to the n. So that's common. Open bracket, 7 squared plus 1. Okay, that's 7 squared. And there's 1 times 7 to the n. So 7 to the n is okay. And 49 plus 1 is 50. So the answer is 50 times 7 to the n. And I think that's all we need to do for that one. Just use similar methods to simplify. Okay. And again, in question 17, there's a few others to practice. And I think we've got one more on the next page. So in question 18, again, this is probably the hardest one you'll have to do. So using methods to simplify from the last few questions to simplify. Actually, we've got 2 more pages to go. So we need to look at how to factorise. There's nothing we can do when we're adding. We can't change that, but we can factorise. Now, 6 to the n is 3 times 2 to the n plus 3 to the n all over. Now, on the bottom, I'll simplify that. No, I won't. I need to reverse that first. So I've got 2 to the n times 2 to the 1 plus 2 to the 1. You can just put a 1 there. So on the top line, I can put a 1 there and a 1 there. Now I can multiply powers in and powers out. So I've got 3 to the n times 2 to the n plus 3 to the n over 2 to the n times 2 to the 1 times 2 to the 1. Now we can factorise. So on the top, 3 to the n is common. Open bracket, 2n plus 1, because I have to leave something behind. On the bottom, 2 is common, 2 to the 1, leaving behind 2 to the n. That's a plus sign there, sorry. That's a plus sign, plus 1 again. And then this factor is the same as that factor. And so the answer is 3 to the n over 2, which is looks a lot neater. So again, there's a couple more in question 18 to do. And copy that down when you're ready to come across, and got one more to go. Okay, so this is question 20. Again, it's just trying to upset you with fractions and negatives, and let's just see how we go. So A is this number, B is this number, and in the first one, I'm asked to multiply. So I put 2 to the half plus 2 to the minus a half, 2 to the half minus 2 to the minus a half. Now I could use FOIL it out, just go FOIL, but you might recognise you've got A plus B, and you've got A minus B if A is 2 to the half and B is 2 to the minus a half. And then this is the difference of 2 squares, A squared minus B squared, which means you just have to square that number. So square that number the half, so we've got 2 to the half squared minus 2 to the minus a half squared. And a half times 2 is 1, so the answer is 2 to the 1. And minus a half times 2 is minus 1. And it doesn't say to leave them, like that might be the answer. So let's just assume that the answer can't have negative indices. So we've got 2 minus 1 over 2 Okay. Yeah, we've got to simplify fully. Like 2 to the 1 minus 2 to the minus 1 doesn't make any sense. So 2 to the minus 1 is the same as a half. So 2 minus half equals 1.5, and that would probably be the neatest answer. And again, in question 20, there's heaps more to practice. Okay, so that's the end of indices number 2. Next one we'll do indices number 3. We'll be looking at indice equations that are a little bit trickier. So stay looking on. So this exercise here is just straight out. Just keep on the Cambridge book, which is on your Moodle page, and you've also got a hard copy. Thanks, bye.